So if you've heard me talk before, you might have heard me speak about estimating risks from AI systems or using AI systems to estimate risks to biodiversity or to the climate. That's what a lot of my work is about, understanding at a technical level based on extensive simulations and projections. What are the risks? How can we break them down? How can we mitigate them? And I think that's very important research. I'm still doing a lot of it. And I think many more people, I invite you, if understanding risks better and mitigating them, it appeals to you, please, we need many people doing that research. However, that's not what this talk is about. This talk is about my reflections on the fact that, to a large extent, either we understand the risks pretty well, or they're so speculative that understanding them better is in itself a difficult research problem. So what can we do to be prepared for these two different situations, things that we already understand and things that we are beyond our understanding currently? We do this a lot for many other kinds of disasters where we don't know whether something will happen, but we think it might. And so how can we be prepared in a robust way, kind of no matter what happens? What I'm going to present to you here is a research agenda, or maybe I prefer to say an action agenda for disaster preparedness for AI safety. So here's the high level. Maybe this is hiding an important point here, that all of these actions may be done concurrently. I'll put this back here. Are you still seeing the slide? Okay, good. Yeah, so all of these can be done concurrently, and roughly speaking, they are ordered from in order of proactivity, how proactive they are. So I'm going to talk about each of these a little bit more, but first, let me tell you a little bit about the rationale behind this list. Why are these things here and not other things? The idea with the things on this list is drawing from my experience in ecosystem modeling. So my degree was in ecology before AI. And the way we think about stability in large-scale complex ecosystems is really based in the way that we model fractal. So things that are fractal, it means that they have repeating patterns at multiple scales. So think of like a cauliflower, or maybe you've seen some psychedelic patterns, or a coastline. It's as you zoom in, the pattern is self-similar to itself. And this kind of pattern creates stability at multiple scales. So if you have a pattern of reproduction of cells that has a certain pattern to it, that organism is more likely to survive than one that doesn't have this self-similarity at multiple scales. So taking these insights from ecosystem theory and fractal stability, the rationale behind choosing these actions, the 9 things on this agenda, are measures that work at multiple scales. So you can think about any one of these elements of the action agenda as operating at as small as an individual level, so building human back channels, maybe having your own human systems for like a t-shirt as a backup to giving your slides. Or we can think of them at a global scale of having backups for systems that we may be increasingly offloading to AI. With that little rationale, let me get into the details of the elements of this agenda. First, designating AI-free safe zones. This means both physical areas and also online areas. Let me say something about physical areas. Maybe you've heard of the Half Earth Initiative. This was proposed by E.O. Wilson, an ecologist and biologist, I think in the 80s, but a long time ago. And it has since been robustly studied as the amount of Earth that would need to be dedicated wild. So the same way we have protected areas of Earth right now where you can't do like mining or development. If we had half of the Earth devoted that way, then we could be quite sure that global scale systems like the current that keep our ships moving and that keep our atmosphere protecting us from solar rays, all of these whole global Earth systems, If we had half of Earth devoted to its wild systems, we'd be able to maintain those to a high degree of certainty. And that might sound like a lot compared to the amount of people on Earth, but it's actually not that much. We're not that far away from it. This is an achievable objective with some global coordination and with initiatives like grassroots, just in your own community, having better habitat zones and rewilded forests, increasing biodiversity helps with this initiative. That's physical areas, areas that are free from AI. But I also mean this in a more abstract sense. So maybe we run some large-scale experiments where some provinces, some jurisdictions, some schools do and don't use AI. This increases the robustness of the overall system if there are some AI-free safe zones. And this could be cycled over time, where maybe it becomes common that AI is used in certain ways for only certain calendar months of the year, or only for certain types of social functions. That's AI-free safe zones. Next one, increasing power diversity, increasing diversity in who is making decisions and who are the people who are leading the orgs that are making decisions. So this could be at your individual level. It could be, who are you asking for advice? Where are you getting your information? If you're trying to validate whether an AI has given you a correct response, are you validating that from a textbook and from your grandmother and from some friends who are a little bit expert in that area? And then at a higher level, at the country level or in global coordination between countries, having not only maybe the president involved in negotiations, but also a random selection like juries from different countries involved in this and having decision-making power. 3, building human back channels. This might sound a little bit like the AI-free safe zones, and they do work together very much, but this is for any given task that you're trying to do, there should be a working human backup. So again, Max's t-shirt is a good example of a backup for a PowerPoint slide. But we could even mandate this in various governance forms. So any military operation that is using AI should have a human fallback, so that should the AI go rogue or deceive its human operators, there's a way to fall back to a human system that doesn't create a catastrophic situation. 4th one here, building off switches, you may have heard of as a very popular technical solution, or even non-technical solution. There are many AI safety advocates who for many years have been advocating for off switches. And there's a very common anecdote of a power plant a big data center in, I think, Stuttgart in Germany, in which there was a small fire. And this small fire turned into a huge disaster where even, I believe, somebody was killed because there was no off switch to the data center. Data center's design does not, in international standards, include off switches. And we can imagine wanting to have these off switches that are controlled, again, increasing power diversity and how they're controlled. We definitely want to have these off switches for certain models, for certain classes of model, for certain operations. But the reason that I put this number 4 instead of number 1, you might think that this is a very basic level thing, is because I think unless we have the first 3, so some safe zones, some diversity decision-making power, and some human backups, it's unlikely, even if we have them, that we will have the financial incentives to flip these off switches. Right now, if you introduce an off switch into every AI system, I kind of suspect it would never be used, just because the economic incentive to keep the system on is so high, unless you have working human backup channels that are kind of ready to go. And that so 1 through 3 decreases the kind of negative side effects of actually flipping the off switch, and therefore makes the off switch actually functional. The next 3, I say I don't play favorites, but like these are kind of my favorites. These are the kind of crunchier, bigger problem size ones, and these are the ones that I'm going to be personally focusing a lot of my research on in the next few years. Decentralizing resource management. Just in general, anything, the more you have centralized control, so imagine having one government led by one person that had control of all of the land on Earth. That would be much more vulnerable to take over by a rogue AI system or take over by a malicious agent of any kind than it would be if land and water and everything else is managed by many different different agents, different people, different countries. And so decreasing the centralization of land, water, social media, the internet, agriculture, to, for instance, localized land co-ops, people who have a vested interest in genuinely ensuring that the land is managed well. I think this is a crucially important long-term sustainable just management of the Earth's resources strategy. And it also means that they're less vulnerable to takeover of any kind, whether it's a fascist government or an AI system. At a personal level, this means not putting all your eggs in one basket, not only using, let's say, one email address or one online document management system. We always, I'm sure we've all had a situation of turning in an assignment where we forgot to push save and it wasn't saved in an online backup. So having backups, decentralizing the management of resources. Number 6, deploying warning systems. So as we've talked about in the panel, we've done a great job as an international community, I think, of identifying important red line crosses. So let's operationalize those into big blinking red lights that people will actually pay attention to. A lot of this is just very simple software engineering, monitoring like journalism, monitoring publications. We could use AI for this, so bots online. We could also have humans. We could employ journalists and software developers to make these kinds of warning systems. You could set up on your own phone, and people could create tooling to set up warnings for when systems cross red lines that you personally decide that you don't want to use an AI system if it does X or Y. Maybe this isn't even about AI safety so much as like resource use. If you're very concerned with climate and ecological impact, you might want to deploy warning systems for when a certain company surpasses a certain level of carbon impact, and then you might no longer want to use those systems. Like these kinds of just basic warning systems, sending an automated email to a mailing list, that level of technology could be very powerful in changing people's behavior and therefore changing the incentives for companies not to cross these red lines. So I think we've already seen lots of, basically all the red lines we discussed being crossed, but those red line crosses are maybe not well known about. Number 7, introducing multiple redundancy. Back channels, off switches, decentralization, warning systems, these are all really important. But if there's only a single one of those things for a given purpose, that's still a vulnerable system. So we need multiple redundant versions of all of the things I just discussed, which means lots of opportunity to have an impact. Even if somebody has already started deploying some warning systems, there's plenty of other warning systems that need to be made, backups, independently redundant systems. Lots of work to be done. And then the last 2, kind of the most complex and requiring the most coordination, but again, the whole idea of this agenda is that small versions can be done by anyone independently. So first, establishing quarantine protocols. If something goes wrong, let's say a warning goes off, or a red line has been crossed for whatever reason, you saw a publication, how do you wall off an area from personal impact? How do you prevent yourself from being impacted by a system that you don't want to be impacted by? Or at a global or country level, how do we wall off a model from impacting other jurisdictions? How do we move, if there's a physical aspect to this, maybe we need to wall off a data center, and that data center is near a border crossing or on a major highway. How do we move people and supplies and make sure it doesn't affect daily life? Once we've established all of these danger zone protocols, do we just keep them in forever? Do we just abandon that data center? Do we abandon this website or this model? What kinds of tests do we run to establish that the danger has been quarantined, has been contained, or has been removed? And how do we return to normal? How do we revert to a certain backup of a model? Or how do we restore a data center to a version of software that was using before? How do we reinstate people's positions if they've been removed, etc.? Finally, putting it all together, conduct drills where we pretend that things go wrong and we test out 1 through 8 procedures we've put in place. This can involve scenario planning where you fictitiously imagine that, whether with people or with a computational model, you imagine that a scenario has gone wrong, or even real world holistic drills like red teaming exercises. I think red teaming has been one of the major successes of the AI safety community, something that we borrowed from the InfoSec community. These things really work to discover things that could go wrong. So let's scale those up to not just technical issues, but socio-technical scenarios where something goes wrong. So that's the research agenda, disaster preparedness for AI safety. If you are interested in this line of research, I encourage you to contribute to the technical report, and I would love to take your questions.
Thank you, Professor Maharaj, for sharing us such a clear and actionable framework for AI disaster preparedness. So now I think we have time for a couple of questions. Anyone who have a question, please feel free to raise their hand. 请工作人员递上麦克风，这边。
I just want to ask, this safety model is for America or for the Union or for our China? Thank you.
I'm not sure I understood the question perfectly, but I think you asked, is it for, like, who is this for, basically? Who is this disaster agenda, action agenda oriented toward? And I really want to emphasize anyone at any level. If you have a local community group that wants to establish policies for your city about having some schools that don't have AI, to maintain the curriculum and old-fashioned methods of teaching, if you want to get involved with your government designating national parks that preserve biodiversity. I mentioned the multiple redundancy aspect of this, how I chose the 9 things in this agenda. Another side to that is that these are all things where I think the downside risk is very low or non-existent. I don't think this is the case for all interventions that would increase AI safety. I think some things it's like, well, if we increase the alignment of a model, that's a good thing for AI safety, but also it could be more easy to get it to do malicious things if it's very easy to align to somebody with malicious intent. So that's a negative for safety. So a lot of things that we might look at in AI safety are dual use, but I've tried very hard to make things in this action agenda not so dual use. So if you create more human backup systems, you're increasing the viability and value of human labor. I think that's great. I don't think there's a downside to that. And same thing for, increasing biodiversity or doing safety drills. As Professor, I forget who it was who said earlier on the panel, you always want to have a contingency plan, even if you don't use it. So it's really at any level of government, at any level of individual action, I think the things on this action agenda are useful for ensuring safety, and there's very little downside.
I see Professor Xue Lang have a question.
Hi, Tegan, I was the one that talked about the contingency plan. And I think I really enjoyed your presentation, and I think this is really a wonderful setup, set of things that could be done. I think on your last point about having a drill, and I think that I'm just curious whether you have developed any sort of scenarios that actually would prompt people to because I think we think about we want to have a contingency plan or you have a drill, you're always in response to some kind of a certain scenario that potentially will generate damage. And I think for the AI, preparing for AI, a safety-related kind of disasters, I think that the question is, what kind of scenario do we have that we human society might suffer its damage? So I'm just wondering whether you have a sort of like a data set or sort of a data bank, whatever, to what are the potential scenarios. Of course, we can always get from sci-fi movies and so on. That's certainly one possible source. Anyway.
Yeah, I mean, I do think artists and other people are underutilized in terms of imagining what our future could look like in these scenarios. But a big part of my research is in exactly this kind of scenario planning with AI, what I call deep risk assessment. So looking at a given risk and how it might play out over time. I don't have like a list of kind of narrative scenarios. I think that would be a very helpful thing to have. But I do want to make a distinction between two different kinds of drill. So there's a drill that responds, as you just discussed, to a specific risk or a specific scenario, like preparing for a hurricane. That the hurricane has particular characteristics and specifics that we need to prepare for, and we need to know about the nature of the hurricane in order to adequately prepare. Like a hurricane of a class 5 is going to have different impact than class 1. So that's the kind of thing where I think my deep risk assessment and other scenario specific contingency plans is important. But I'm actually advocating here mostly for a different kind of drill that does not depend on the specifics of a scenario. The drill is about our disaster preparedness measures. So regardless of whether we know the nature of the risk or not, we can still test whether the human backups work, whether the off switches work, whether we in fact have the amount of protected land set aside that we think we do. So audits of those kinds of measures. If we have quarantine measures of like turning off a certain data center and rerouting internet traffic around, like how much downtime does that result in? How much does it cost? So we have realistic predictions of when we want to do those more scenario specific tests, we know how much it would cost to implement our disaster preparedness measures. So on the one hand, I think it's very important to know scenario specific things, but I also think we can run scenario agnostic drills and disaster preparedness, and that's mainly what I'm advocating for here.
Oh yeah, so hi Tegan, thank you so much for your insightful speech. So I'm just curious about your quarantine measure. Like what does it look like, and how it is different from your first point, which is to designate an AI-free area. Like, can you expand more on that?
Yeah, great question. I think those are very similar, and a lot of quarantine measures might depend on having AI-free safe zones. But let me say what's different about it. I think it's the one on here that is maybe we're the least prepared for, that the least has gone into. So if you find it intriguing, maybe this is the one where there's the most opportunity to like, create the first quarantine protocol for AI safety. I do have some ideas about how it can be done. A lot of it based from the InfoSec community, so information security. If a given data center is experiencing a DDoS attack, for instance, there are certain, I'm not a computer security expert, but like there are certain protocols and like it's planned for in the way DNS routing works, that certain nodes in the network can go down and traffic can be routed around them. So I think the same thing could be done for AI systems if we had better tracking of like, where is the AI? We don't actually know or have audit trails of that a lot of the time because results are cached in different ways, partly because of the way inference works. So token level aspects of queries are cached, but also I suspect the companies are caching like weights and maybe intermediate responses or latent variables that enable intermediate responses. there's only so much we can know about how that works. And so there's only so much quarantine response we can do from outside these companies. So one aspect of quarantine response, similar to auditing, could be mandating cooperation of certain kinds from companies. So if a red line is crossed by a system, then they are mandated to allow us white box access to their systems in order to better implement quarantine protocols. I could say a lot more about this, but I want to give some more time for questions. I hope that was a little bit, gave some more context.
Okay, thanks, Professor Maharaj. I think time is up, so we really appreciate your time and valuable insights. Thank you.